We're going to quickly go over some basic data wrangling or data cleansing manipulation with Pandas. And we run through this, make sure everything's in place. So the first is the ability to modify cells to get them into a different form. And so to illustrate this, I'm going to use our elevation data. So here we have a ranking of states by average elevation, where we have the rank of the state, the name of the state, the maximum elevation, lowest elevation, and the average elevation. So a couple of things to point out is, first, in the cell we have numeric values and units. And so Pandas is actually, as it reads it in, is recognizing these as strings, not as a number. Where you would, for consistency, expect sea level to be reported as 0 feet, it's represented as sea level. And so we have some data inconsistencies here that could be a problem for our computation. So first off, we would want sea level to be in the same format, so like 0 feet. And we would really prefer that the units be in a different column so that we could manipulate these elevations directly as numbers. You can split columns within Pandas, which would be a nice solution, and it's not what we're going to explore here. What we're going to do here is modify the cells using, in this case, we'll illustrate using the replace function. So the first thing we want to do is we want to take this data frame and we want to replace everywhere where it says sea level with 0 feet. And replace returns another data frame without modified, and you see now we have 0 feet. But feet are still going to be a problem for us because it keeps Pandas from recognizing these as being numeric values. And so we really want to also get rid of the feet. And so we can do it the same way that we did with replace, but also, just as a trivial illustration, we can use regular expressions, which we'll talk about later in the class, which can be used to modify variable types of expressions. And again, so in this, we use the replace function. In the first case, when we're replacing sea level, we just provide a string literal sea level, and what we're going to replace it with, 0 feet. In the second case, we're providing, instead of a string literal, a regular expression, and what we're going to replace it with, in this case, an empty string. So we start with our data frame elevation. We call its replace method with arguments sea level and 0 feet. That returns a data frame, so we can chain these method calls together. So at this point, we have a new data frame, and we're calling the replace method for that data frame with a regular expression and an empty string. So then at this point, this now becomes a new data frame, and for that data frame, we're writing the data out to a CSV file with a tab separation instead of a comma. While there's, in the last notebook, we saw that there was a read table and a read CSV. There's only a to CSV, so we've lost our parallelism there between our input and output functions. But nonetheless, I'm writing this out to disk in a file called elevation2, and then just kind of repeating that here so we can see what it looks like. That we now have, we've gotten rid of our sea levels and we've gotten rid of our feet, and we have what looks like numeric values. However, these are actually still strings because this 14,440 is a string representation of a number, not a numeric representation. So we can see that here, that's a string. And so what we really want is we want numbers so we can do computation with it. Pandas has a convert objects method, which will allow us to try to convert the different cell values, and you can read the help here. But there's a convert numerics form, and that's not working. That's not working because it doesn't know how to deal with that comma in the number, in the string. So we have two approaches to this. As I kind of hinted at in the last notebook, when we read in the data, Pandas knows how to, if I provide the thousands keyword, to say what character is separating 1,000 values in a number, then it can read the numbers and read the strings in and convert them to numbers without problems. We can also look at using the locale package, and the locale package provides ways of customizing Python to recognize different formats, for example, representing numbers. In France, we would use a comma as a decimal point instead of a period, and so forth. So it allows us, and there's things for currency symbols, etc. So the locale, if you're using data that comes from multiple parts of the world, becomes very valuable and important to get all your data into a common format that you can work with. So the first solution, as I mentioned, is just to provide the 1,000 separator keyword in a read. And now it's able to read, and it's converting them into numbers, just like we would hope. The other approach is to use locale, and locale is more complex. And what we'll see is it's recognizing that from my computer settings, it's saying, well, you're an English US speaker. So it's going to be expecting English with US style in the data representation. So we can set the locale. So in this case, I could be working with data from France, even though it's recognizing from my computer that I'm in the US. I might have French data, and so I could set my locale to be France, and then do my manipulations that way. And so what I'm going to do is I'm going to set the locale. I'm going to tell it to set the numeric values to represent my current location. I'm a little confused by this empty string here, but that is necessary for when I'm setting my locale. So essentially, I'm not telling it what locale I'm at. It's recognizing from my computer, and it's setting the numeric conversions to represent what would be consistent with US usage. And I'm going to use the data frames apply method to apply a function to each element. In this case, I'm going to apply to the lowest elevation and highest elevation and average elevation columns of the data frame. Now, lambdas are something we haven't really talked about. These are anonymous functions, kind of an extra topic that we're not going to dwell on in this course. But essentially, I'm taking as an argument a row in the data frame, and to that row, I'm applying the locale A to F. So this is convert a string to a float function for each lowest elevation value, for the lowest elevation value in that row. And I'm doing the same thing for the highest elevation and the average elevation. And when I'm done, I have my numeric values like I was able to get from the read function. All right, so that's a couple of illustrations of modifying cell values. Here I'm going to create a whole new column, which I'll call range elevation, which will be the difference between the highest elevation and the lowest elevation. And so again, I'm using the apply method of the data frame, and I'm going to apply this lambda function, this anonymous function, anonymous meaning I haven't defined it and given it a name, which is going to take as an argument a row of the data frame, and it's going to pull the highest elevation value from that row and subtract the lowest elevation value from the row. And this is just saying that I'm iterating across the rows and not the columns. And when I do that, you see I now have this new range elevation column in my data set. So I've been able to modify cells, and I've been able to add cells, add columns. And you can see here that Utah actually has a pretty high elevation range. I think that we're only going to, let's see, we're beat by Hawaii, California, and Alaska, and Washington, and we get Oregon. Anyway, all right, so we're able to create a new data column. Okay, we also need to be able to drop values from our table. So in this case, I'm going to drop rows based on some conditional. So I'm going to say I'm only going to keep rows where the highest elevation is greater than 8,000, which leaves me with 17 tables. And there can be a lot of varieties of how I'm doing it. So you see the syntax is I'm taking the data frame and I'm taking a column from the data frame and asking a question about it. Okay, let me read it in a data set. This is some reports from the Mimic data set. Again, this is a recognized data format from Python. And so there's a whole libraries like the time that I used in the last notebook. There's date time and there's calendar modules that are worth looking into if times and dates are the type of data that we're going to be working with. You can see we have a lot of missing values here in this data set, just not in numbers everywhere. And so Pandas provides me the ability to just drop values, drop rows and columns where there's missing values. And so this is through the drop NA method of a data frame. And it has this keyword how. And so I can tell it to drop rows or columns where there are any missing values, and what you see is we end up with an empty data frame. Or I can say if all the values in the row or all the values in the column are not a number, then we'll drop those. And see what we actually, so 100 rows, 15 columns. And when we're up here, how much did we have? Scroll up, scroll up, scroll up. "100 rows, 15 columns." So in this case, we didn't drop any. But for a more realistic data set where we have things kind of mixed in, we would use drop NA to drop rows with missing values or eliminate columns. All right. When we read in data, there are some values that Pandas is going to recognize as missing, such as none or null. But a data set might use a different symbol to indicate missing data. So for this accidents data from the UK, they use a -1 to indicate that there's a missing value. So I can tell it, I can provide a list of symbols that indicate missing values. And so here I am reading in the data, and whereas before we had a -1 for pedestrian crossing physical facilities, we now have a missing values. And just to compare that, just to show you what the original looked like, to remind you that we had -1s for those values.